Hello to all of my friends at the Clay Center, and thank you for joining me for today's at-home Rocket Racers session. I'm Josh Rebels, and I was born and raised in West Virginia, and throughout my life, I've had some amazing opportunities presented to me, one of which was racing my family's dirt track race car for an entire decade at racetracks in West Virginia. Now, a lot of people know about the adrenaline rush of the sport of racing, the head-to-head competition against other racers. It's a lot of fun. But if you stop to think about all the time and effort that goes into engineering, building, designing, and maintaining a race car, you look at the sport a little bit differently. In fact, it actually takes a lot of knowledge of the laws of motion, science, and technology in order to do it well. Thankfully, my current job as a teacher at the Katherine Johnson NASA Independent Verification and Validation Education Resource Center has crossed over into helping me prepare students to work in the STEM field. And so you could see yourself working maybe in aerospace, with rockets, coding robots, and even just space in general are things that I work with students with. If after today's session you'd like to learn more about rocket racers and a competition that I have going on, then you can email me at jrebels@fairmontstate.edu, and we'll schedule a full training session on rocket racers where you can learn more about laws of motion, speed, acceleration, and a lot more. Here's some photos of the race car I had the opportunity to race. Some of the most memorable experiences in my life come from racing. I enjoyed the sport for many reasons. One of the best things about racing was working on a race team with my family. My grandfather, uncle, and father together built this car and taught me a lot about being a driver and crew member. Over the years, racing has seen improvements in technology that have impacted racing quite a bit. Safety of astronauts living and working in space is extremely important. As you can imagine, the conditions of space are rather extreme and requires some creative thinking to make NASA missions successful. And after many successful rocket launches that have carried humans, robots, supplies, and equipment into space, NASA has helped develop many new things that have helped improve life on Earth. One of those being the sport of racing. One of my favorites to talk about is how the designing of landing gear for the space shuttle to safely return to Earth has actually improved the design of racing tires. Okay, let's race right into building your very first and basic rocket racer. You see, we've got four main parts. We're going to develop the chassis, construct the axles and the wheels, and also attach an engine. Okay, let's start with the chassis. So what you need is a foam tray like this. You can get it pretty cheap at a grocery store. Maybe even someone nearby will donate one to you. And I like these rectangular shaped ones because it makes a really good shape for your car. And so you could just cut out along this crease and have a nice rectangular shape. Okay, so I used a ruler and a marker to draw a square shape, and then simply just get a pair of scissors and cut along that line.
Now for the axles. Take a regular drinking straw and cut it so that it fits the shape of your racer, and then tape it down so that it's attached to the chassis.
Okay, so once those are attached, now you just need a coffee stirrer, and you insert it through the bottom of the chassis through the straws that you put on it. And so now your axles are there, but they kind of move around a little bit. And that's fine. You don't want to tape these in place because if not, then your wheels won't rotate as the car travels down the track. Okay, so now we need to make some wheels to stick onto that part of the car. And so you're gonna need another piece of foam and maybe a cup that has a nice round shape. And you're gonna put the cup down on the foam, and then with your marker again, you're gonna push down on the cup and then draw using the cup as a template. So you get a nice round circle. And you can try different sizes so that you can see if different size wheels make a difference on how fast or how far your car travels. And you actually need 4. So you're going to have to do this step twice. Once you have all 4 wheels cut out and rounded so that they'll travel smoothly, you're going to take a permanent marker or marker, and at the center, you're going to put a dot so that you'll have a little reference point to insert it on the car. And so I'll pick the car back up now, and then I'm going to leave it laying upside down just to make this easier for me. And then you're going to line the dot up that you made with the coffee stirrer, and you're going to push the coffee stirrer through that opening like that. And you're going to do that for all 4 of your wheels. Okay, and then you need to tape them onto the axles. And so you want to make sure that they're standing up nice and tall and vertical, not bent or at a diagonal. And you're going to want to tape on both sides. You're going to tape the coffee stirrer to the wheel. And then after you get all of them taped, you're going to have to adjust just a little bit to make sure that they're all standing upright. And then your car should move back and forth like this. Okay, now for the last step, which is adding the engine. To do this, you're going to need at least 1 straw. I'm going to use 3 straws because I like having a little bit bigger exhaust on my Rocket Racer. And you're going to find a place on top of the chassis to put them, because the air is going to flow out of the balloon through these straws out the back of the car. And so I'm going to use the bendy straws to kind of lift them up here so that I can lift my balloon off the top of the car so that it doesn't get in the way of the wheels while the balloon is inflated. So about like that. And then we're going to tape it down. Okay, so I've taped the exhaust down to the top of the chassis and left enough space on the back so that I can blow air through the straw to blow up the balloon. But before the balloon stays inflated, you actually have to tape it so that it seals around the edges and seals shut. We're going to do that next. And it's going to take a hefty amount of tape to do this. In fact, it may even be easier if you do this before you stick it on the car. Test to make sure it's sealed. So I'm going to inflate the air into the balloon. And I'm going to pinch the back. And if I hear air flowing out of the balloon, that means there's a leak. So I've got to find it and seal it up. Okay, for the most part, I think I've got it sealed now. So again, I'm going to inflate the balloon with air. And I'm going to set it down on the track, and it should start moving across. Woo, that was fast. Okay, one last thing. If your car starts taking off and flying, it's probably because it's too light. We're using a lot of light materials. So you could use some extra straws, tape them down onto the chassis to give your car a little bit of weight, and that should help. So how does it work? Well, it actually uses Newton's third law of motion. Think about a rocket's fuel chamber, pictured here in the middle of the screen. How does a rocket get off the launch pad? Well, it's got a lot of molecules of gas in it, just like the air that I blew into the balloon. Now, when the air is forced out of the rocket, when the chemical reactions take place, it only has one direction that it can flow, and that's out the bottom, and that's how thrust is generated. These molecules bounce around and actually push the rocket up, while the rocket pushes the very small molecules out of the bottom of the rocket. And that's what makes thrust occur. And so with enough force, this equal and opposite pair of forces allow for a rocket to launch and also allows for our race car to zip across the track. Have fun, re-engineer, and make your cars better, and then share them with me. Thanks for watching.